I'm going to talk to you today a little bit about Textile and our journey to Tableland, a little bit about Tableland with this very cool tagline of the read, write, and own database. And we'll see how far I get. I'll try to keep it quick. And then I got a bunch of like nerdy, fun topics that we could talk about towards the end if anyone wants to chat about that stuff afterwards. But I'll start with just kind of the motivation for Textile over the last couple of years and how we arrived at Tableland. And so, you know, it's funny, every now and then I'll bump into someone who'll be like, oh, cool, Textile, you guys are like OGs in this space. I'm like, yeah, but you only have to be here for like 4 years to be an OG in this space, so it's pretty easy, just stick around long enough. But yeah, we've been around for a while, and pretty much since the beginning, our sort of like driving philosophy has been like, how can we accelerate the exchange of information across society? And we came at that problem from first principles, and we arrived at sort of IPFS, and in particular content addressing, as a very clear solution to this sort of like problem. How do we bootstrap and accelerate information exchange? And clearly that is that by linking directly to the information you're trying to exchange in the first place, instead of linking to these sort of like walled gardens and silos of information. Just link that information. And so we started building a lot of tooling in the space because like a lot of other teams in the space, we sort of said, hey, oh cool, like IPFS exists, obviously it works perfectly all the time, so let's just build an application on top of that. And so we built a mobile app. I think it was the first instance of IPFS sort of like really running on mobile. And it was a dual featured thing because it was a pocket warmer as well as an app that you could exchange photos with, so that was pretty handy. So we said, whoa, that was really hard. It took us months to build this pocket warmer, and it worked. And we even in IPFS camp, the first one, we actually used it and exchanged photos, and it was pretty exciting, and it kind of worked. And then we thought, geez, it took us like months of like getting Go IPFS to compile on mobile, like doing all this stuff. We had to create a bunch of tooling to like spin up and spin down the node so that it didn't warm up too hot, all this stuff. And then we thought, geez, wouldn't it have been nice if someone had built all the tooling and things that we ended up having to build to kind of accelerate this, what I like to call time to failure. So basically, wouldn't it have been really cool if I could have found out quickly that building a pocket warmer wasn't a great idea, and I probably could have focused on something else. And so yeah, that would have been great. So we sat back and we said, okay, let's build the database, let's build the like file storage, let's build the mutable stuff that we needed to get Textile photos built. So that's where like Textile buckets and threads and a bunch of other underlying technologies that our team has been working on over the past few years came from. And then Filecoin came along and we thought, oh, let's build tooling for that as well. And this idea of building tooling is going to come up a bunch in this session, obviously. And so that's really where, you know, we've been over the last few years. And then recently our team kind of took a step back and we said, you know, we looked at the space and we started to get a lot more involved in, you know, Web3 more specifically, so like blockchain-driven application development. And we found that the tooling that we had built that worked great in a sort of peer-to-peer setting in the sort of D-Web IPFS world, it didn't fit the development flow and practices that folks building on Ethereum and building dApps and things like that were building. Additionally, you know, we sat there and I don't know, it was like 2018, something like that, 2019, and we were like, oh, cool, the next big thing is dApps. It's going to be great. Everybody's going to be building these decentralized apps, can't wait. And then it was DeFi. And we're like, okay, that's cool, DeFi's great, fine. You know, financial building blocks, that's great. Okay, cool, dApps are coming, here we go, here we go. And then it was NFTs. And we're like, oh, okay, that's, yeah, fine, NFTs. That's okay, pictures of apes are cool. So, and then that was sort of like, okay, these are ownership building blocks. And then we're like, fool me twice? I don't think so. So then we thought, well, you know, what is the next big thing? Maybe it's dApps, probably not. Probably it's like data building blocks or some other building block. Again, because tooling is this thing that when you build it, it bootstraps all these like unexpected other things that people can build. Like who would have thought that people would start building sort of financial products on top of other financial products in some way that is extremely, sort of arguably irresponsible and totally crazy, but exciting at the same time. So what kind of irresponsible things could we do with data building blocks? So many irresponsible things. So, and what even is a database in the first place, really? We know that a lot of people build sort of traditional and future apps on top of relational data, right? Like every app that you use is probably using some sort of SQL database. Maybe some of them are object or document style databases, but like every single one of you has a thing in your pocket with SQLite running on it. And if you don't have a phone, that's super weird. So you probably do have that, and I can make that assumption. So we thought, okay, databases are pretty pervasive, and so what is a database, right? It's access control and sort of like permission to do things. It's indexing and like sort of deciding where everything goes, and then there's some storage layer, right? And so we thought, okay, well, we want to fill that sort of database gap for Web3, and how might we do that? We're like, well, the blockchain is ownership, and the blockchain is rules and access control. So we're not going to build that because there's a bunch of those. Some of them are great and some of them are terrible. And I'm at an IPFS conference, so I'm certainly not going to build a storage, backend because that would be crazy to try and compete with Filecoin and Arweave and all these other things. But that middle piece, that's interesting. I get to solve a bunch of really, interesting, important problems and build an infrastructure that's totally usable for app developers. So we kind of said, okay, let's build that middle piece, right? We won't do access control, we won't do storage, we'll do that middle piece. And so, the idea is if you combine those two, you kind of get this metadata layer, right? This vestigial tissue between applications and their data that allows you to actually index and decide where things are. So we started to build Web3 native tables, and it's literally just tables. There's nothing, sort of fancy, it's very intuitive. And half the developers in this room, especially ones with like longer beards, know SQL, right? It's a very common language. A lot of people end up building with it. So that was our kind of pitch is, okay, let's just build tables. That's it. It's so retro that it's new, right? Okay, that was supposed to be a joke, but that's fine. But let's do that. Let's build SQL, and then we'll store that stuff on a decentralized network of validators. Where they actually finally sort of resolve that data, it's totally up to them. Could be Filecoin, could be IPFS, could be AWS, who cares? And then, because we're concerned about sort of very clear access control in a way that's quite different than how Fission and other teams are thinking about access control, we'll anchor all of this stuff to a blockchain. It can be Ethereum, it could be Polygon. Right now, any EVM chain is what we're looking at, but in theory, it's any sort of ledger. And so you end up with like literally SQL, like that's valid SQL that you could put on the Tableland network. And when you mint or create a table on Tableland, you're literally creating a unique digital asset that has ownership and access control and all that stuff built in and driven by on-chain interactions. And it's designed to play nice with others because why wouldn't we do that, right? All rising tides lift all boats. And so it's part of this sort of like new stack that's developing around Web3 experiences, right? Like I want to have an experience. I don't want to log into a thing and use the thing. I want to experience something exciting. I've already got a wallet. I've already got an address. Let's leverage that. And so it's part of this balanced breakfast right here, where the underlying storage piece is a little bit fuzzy. It can be anywhere. And we've got this sort of infrastructure layer where Tableland plays really nicely with Filecoin and IPFS and the graph and live peer and all of these other things that you're using to store and interact with data. And honestly, what could be more composable than relational data? Literally designed to be composable, literally designed to be interoperable. And the really cool thing is we target a bunch of different chains, and you can push data through sort of mainnet Ethereum if you have money to burn. And then you can push data to Polygon, and then you can do joins and queries across those two tables in very interesting and exciting ways. And there's the tool piece where I can't even imagine what sort of people can start to do in that case. And one thing that people have started doing is creating marketplaces for tables, where you actually can allocate and send and share these like unique identifiers as tables. And one thing I haven't mentioned, and I've got it here, right, is we've got this contract. So every table is an ERC 721 compliant NFT. But you can also control a table with any smart contract. And so you can actually specify your access control rules through a procedural language like Solidity. So you could do things like say, okay, look, only someone who owns a Bored Ape and after block whatever, and according to a Chainlink oracle, it's raining in New York, are you allowed to insert a new row? You can do crazy stuff like that. You can do crazy access control that you couldn't really do in a more traditional database world where someone built all the access control into it. So you can also do things like, look, you're only allowed to write to this row if you own this particular access control NFT, or if you have this much balance in your account, or whatever sort of thing you might imagine. According to some oracle, I'm super into sports, by the way, but some basketball player has scored some number of baskets, okay? You can do all sorts of things like that. I'm kidding, I'm a terrible sports person. So that's the type of sort of application layer stuff that you can talk about. And there's a bunch of examples here of like games, and we have a couple people building games where there's a really cool one where there's like a Mario Kart type game where basically the cart is the table, and it's made up of parts, and all those parts are unique assets that you can own. So you can buy wheels and pieces for your cart, and then you can like soup it up and drive it and beat everybody, and then maybe, I don't know, you can like win their cars. I don't exactly know what the next step is there, but that's sort of where it's headed. Okay. So, and someone's gonna have to just like flag me down and tell me to stop, because I'll just keep going. So again, what even is a database, right? Well, Tableland is really basically two pieces. There's an on-chain registry, and that's the thing that transactions and access control and like table unique identifiers for tables happens. And that exists on every EVM chain that is supported. And then, and that's where the access control lives. And then there's off-chain tables, and that's driven by a network of validators that are basically watching for on-chain state changes and then materializing those changes in literally SQLite databases on every node. So it's really easy to run a node. It's designed to be sidecarred next to an Ethereum node or something like that, or you can use even an Ethereum provider. Because the best way to have a decentralized network of smart contracts is for everyone to use a provider, obviously. No, but it's better if you run your own, but you do what works best. So that's basically how it works. There's these two components. And so really we're talking about sort of decomposing a database into just the little bits that you need. And basically the way it works is the user interacts with the smart contract to create, insert, update, or otherwise interact with some data. It goes through Tableland, right? Get it? Pretty good. And then that data is materialized on the validators. And then you can interact with that data, get the latest state from it by querying those validators directly. Or we're actually working on a libp2p style protocol where you basically ask the network, I would like the results of this type of query, and then you use a DHT in that case basically to go say, okay, cool, who here can answer that query? So that's kind of a fun way to interact with it. And so yeah, no mom, I'm not building tables now, we're just still building software. And so this is how the basic workflow works, right? So you've got a dApp. The user interacts with that dApp. See, I told you, dApps are the next thing, right? It's coming. dApps are coming. They make a smart contract call to either create a table, update a table, change the access control rules for that table, or lock it down so that you can never change the access control rules for a table. And this is a kind of cool concept, so I'm going to take a second to talk about it. So Tableland is all about mutable data, right? You want data changes over time. It's useful to have this mutability concept. And even, in the IPFS world, we want databases and things built on top of the file system to represent mutability, right? So mutability is a useful feature. But sometimes you don't want the rules for how things can mutate to change. You want that fixed. For instance, the rules of a game, like chess for instance, they don't change. Those rules are fixed, but the state of play can change all the time from move to move. And so it's pretty neat that you can deploy the rules for how state can change to a blockchain. Those are immutable and fixed, but they can continue to mutate the underlying data along the way. And so I like this idea of basically like immutable rules for mutable data. And this is a nice concept. And I think we're just starting to realize what you can do when you have that sort of concept, because we've had a lot of people, especially in the NFT world, saying like, if it's a mutable contract, then the teams could rug pull. But if the contract states what the rules are, you've got a very clear, you can look and see like, okay, if this, then that sort of scenarios, you can trust that those state changes that happen are very fixed and clear. And so the way that works is they interact with the smart contract. The smart contract checks access control rules. It's very easy if you know any Solidity to implement it. And then we have a bunch of helpers to kind of do normal, regular type things. The statement is emitted from the contract. The validators watch for those emitted statements. They pull those in. They materialize the view, update the state. And then depending on what particular interaction you were pushing through, they may return a result or not. And we now even have a couple of folks experimenting with using like third-party oracles to push state back on chain. Sometimes that's a good idea, but I can't imagine you would want like a whole database query to somehow be back on chain. What even would that look like? I'm not sure, but you can start to imagine these things. And then of course you want sort of like proofs of what the state on the Tableland network now looks at, and lo and behold, content addressing and hashes and things provide exactly what we need there. So I'm going to kind of wrap up now. Hopefully you have a sort of general idea of what Tableland is. And I barely scratched the surface of how Tableland can interact with the IPFS ecosystem, but it's a bunch of really cool ways. Including things like embedding hashes in tables and then seamlessly fetching the data behind those hashes as you do queries and writes. So imagine sort of like pushing an image to a row in a table where you transparently or seamlessly actually push that to IPFS, calculate the CID, stick the CID in, and then push that update to Tableland, and then on the way back out you do the reverse. So there's a bunch of like sort of fun, interesting things like that. But here's some interesting topics that I'm totally down to nerd out with you all on later. Database implementations. There's a bunch of really cool stuff kind of happening under the hood here around data structures and IPLD and how we exchange updates and interactions in the background. If anyone wants to chat about proofs of database state, I'm here for that. If anyone wants to chat about proofs of like SQL queries, there's a really, really fun, hard problem there that some folks have started to look at, so we could totally talk about that. Blah, 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 blah. But most importantly, let's also talk for the rest of this afternoon and the rest of this session about building tooling and developer tooling in particular on top of these sort of interesting primitives. And I've got a lot of opinions about that as well, so I'd love to deep dive with you on any of these topics. But the last thing I wanted to talk about before I leave is some people. So Tableland did a whole bunch of branding stuff. We've got these like this sort of cool, I don't know, future retro vibe. And a bunch of people are like, oh, I thought you guys were like an NFT project now. That is not the case, but we do have this NFT project called the Rigs, which basically our community members hold these rig NFTs. So that's what rigs are, and if you're wondering what the heck they are, that's what they are. They are a sort of utility NFT. But what they really are is that they're an experimental platform for the Tableland network. So all of these NFTs, their metadata is driven by tables. And their metadata is actually driven by like relational tables, and we can extend their traits and all sorts of crazy stuff by leveraging Tableland. And so we basically experiment with like real UX and a real product on top of Tableland by leveraging these rigs. Plus they look pretty cool, which is like a nice side feature. Unfortunately, they ended up being slightly popular for a little while, so now they're kind of expensive. But we've got some other tooling coming in for developers who just want to get in and start tinkering. And we've got some testnet ones as well if people want to play around. So rigs are an experimental platform for the Tableland network, and vice versa, where Tableland network is an experimental platform for an actual production NFT. So there you go. Thanks very much.